Hi everyone. So the reason I'm recording this video today is because in some of my previous coursework videos, I was teaching a statistics class that made use of the TI-84 calculator, and more recently, I've gone away from this. More recently, we are getting away from using the TI-84 calculator and instead using the TI-30X2S calculator. And the TI-30X2S calculator won't be able to do some of the functions that the TI-84 calculator was able to do. And so when you watch these older coursework videos, it's not going to be true to life to what you will be doing on a test, because on a test you'll have this calculator. And so one of the things that I want to make very clear is on a test, if you were to have a question like this, how would you answer the question, right? And so let's go ahead and jump in. Suppose you have a 3-month-old female baby. She weighs 15 pounds, and the average 3-month-old female is 12.9 pounds. The weight of female 3-month-olds, let's suppose, is normally distributed with a standard deviation of 2.2. And the question is asking, what is your baby's percentile? In this question, when we're asking for a percentile, the first step is to calculate the z-score. And calculating the z-score means I take the measurement minus the mean divided by the standard deviation, because the z-score is telling us how many standard deviations are we away from the mean. And so we do something like this. 15 minus 12.9 is 2.1. And then I believe this rounds to 0.95. And what do you do after this? In a previous video, I may have said, go ahead and pick up your TI-84 calculator and punch some numbers into your calculator and use the built-in functions there. But what if we don't have the TI-84? What if we only have the TI-30X2S? Then what do we need to do? We need to use the standard normal distribution CDF table. And I will give you one of these tables whenever you go to take a test. I will give you a standard normal distribution CDF table. CDF stands for cumulative distribution function. You don't have to remember that. You don't have to know what CDF means as long as you remember how to use it. And this is what your CDF table looks like. And keep in mind that our z-score was 0.95. And the way you read this table is if you have a negative z-score, you're going to use the numbers on the left where you have the minus signs. If you've got a positive z-score, you're going to use the numbers on the right where there's positive signs. And then you're going to look up 0.9 and I'll highlight it for you so you can see better, and then plus 0.05. Because 0.9 plus 0.05 is going to give us that 0.95, and at the intersection of this row and this column, corresponding to 0.9 and 0.05, that intersection is going to tell me the percentile. And so let's zoom in really quick so we can see what that percentile says. And for 0.95, we've got 0.8289. Okay? So we found 0.8289 as our percentile. Of course, this is given to us off the lookup table as a decimal. If I want to convert that to a percent, I just have to multiply by 100. So multiply by 100 and we have our percent. And this baby is the 82.89 percentile. In other words, this baby is heavier than 82.89% of the population, but still lighter than 17% of the population. That's where they would rank, if you ranked all of the babies from heaviest to lightest, this baby would be heavier than 82.89% of the population. Okay, let's do one more example. Maybe a few more examples if we have time. The next exercise says, for intelligence quotient, they design IQ tests so that the mean of the population should be around 100 and the standard deviation of the population should be around 15. That's the goal. And of course, this doesn't always work out exactly, but they try to design the IQ tests and they try to score the IQ tests in such a way so that our mean is 100 and our standard deviation is 15. And this time, we're saying, suppose that you take an IQ test and your score comes back as 130. What would that mean for your percentile if your score is 130? Well, the first step is to calculate your z-score, and your z-score follows this formula. So we take 130 minus 100 divided by 15. That's, of course, 30 divided by 15, which is 2. Our z-score is 2. Now I'm going to use my lookup table, the same one as before, and this time my z-score was just the number 2. And so I just look right here, 2, and I don't want to add anything to the 2 because it's just 2.00, right? And so I look in this first column and I get the decimal 0.9772. So my decimal is 0.9772. That's from the table that you'll be given on a test. And then, of course, you want to convert this to a percent by multiplying by 100. So multiply by 100 and we get 97.72%. In other words, if your IQ is 130, that means you have an IQ that's greater than 97.72% of the population. That's your percentile. And we haven't done any negative numbers yet, so let me make up an example using negative numbers, right? We'll give this a try. What if you have a second baby, and at 3 months old, this second baby girl has a weight of 11 pounds? So this is a new problem, where the second baby girl has a weight of 11 pounds. Then we calculate the z-score, because we want to know the percentile of this new baby. And of course, it would be 11 minus the mean divided by the standard deviation. And 11 minus 12.9 is going to be negative 1.9 divided by 2.2. And this is where you pull out your TI-30X2S calculator and you type in what is negative 1.9 divided by 2.2, and we get the answer 0.86. And that's our z-score. We only need to round to 2 places after the decimal, because whenever I go to look at my standard normal distribution table here, you will see that you can only really get 2 digits after the decimal for your z-score anyways, and we are looking for, I already forgot the number, 0.86. And by the way, that was a negative 0.86. My mistake, but we didn't lose the minus sign here. When we have negative 1.9 divided by 2.2, that should be negative 0.86. And now I can use my lookup table. I'll find negative 0.8. And then I also need not just negative 0.8, but I need the negative 0.06, the negative 0.06, because that way negative 0.8 plus negative 0.06, when I add those together, I get the negative 0.86 z-score that I'm looking for. And at the intersection of this row and this column, we find the z-score that I'm looking for, which is 0.1949. And this is what we got from looking at the table. Once again, I need to convert this to a percent, and I convert this to a percent by multiplying by 100. And so the percentile for this baby is 19.49%. That means for an 11-pound, 3-month-old female baby, the percentile would be about 19.49%. That means the baby is heavier than 19.49% of the population and is lighter than 80% of the population. That's where they sit. Percentiles are useful in this case because it allows a pediatrician to know whether or not they should be concerned about the development and the growth rate of a particular baby. Because if you had a percentile for your baby that was, let's say, less than 5%, meaning that they are lighter than 95% of the population, that might be a little bit of a cause for concern. And maybe you need to switch to some kind of formula that has a heavier calorie density, maybe more protein to increase the rate at this child is growing. Or what if it's a really, really heavy child? In fact, what if your child is in like the 99th percentile? They're heavier than 99% of the population of 3-month-olds. That might be a cause for concern. But we'll do one more example. Suppose you take another IQ test, and this IQ test tells you that your IQ happens to be 95. Then we calculate your z-score as being your measurement minus the mean divided by the standard deviation, which would be -5/15. And putting this in your TI-30X2S calculator, you would be able to calculate a z-score of -0.33. And with a z-score of -0.33, we find this row for -0.3, and this column to add an extra 0.03 there. So we are looking at this column here. And at the intersection of the -0.3 row and the -0.03 column, this intersection is going to have the percentile that corresponds to my z-score, which is 0.3707. So then I get 0.3707. And converting that to a percent makes it 37.07%. And so with an IQ of 95, that makes you smarter than 37.07% of the population. That's how we interpret percentiles, and that's how we find percentiles using the standard normal distribution CDF table. Some of you may wonder, at the top of the standard normal CDF table that I prepared for you, there's two pictures. Both of these pictures have a normal distribution bell curve and some shaded area underneath the curve. And I included these pictures because on the left table, where you've got negative z-scores, well, a negative z-score tells you that you are below the mean, and that means you are at a point less than halfway through this bell curve. In other words, you're on the left side of the bell curve. And I'll say this, the entire area underneath the bell curve, if I shaded in the whole area underneath this bell curve, the entire area underneath this bell curve is 1. And so now, if I only shade a particular area under the bell curve corresponding to where your z-score falls, then the area of this shaded region is given by the decimal that you look up. And the picture looks like this on the right if you have a positive z-score, because a positive z-score means you're greater than the mean, and greater than the means you'll end up on the right side of the bell curve, and so the area of this shaded region is the decimal in this table. And so that's the picture here. There's one other thing I can show you. One other thing I can show you while we're on this topic, which is just this nice Desmos calculator that I put together. And so you can see the normal distribution bell curve, and you can kind of understand how the CDF function is calculated. You know, you give it an input value, which is a z-score, like maybe the z-score of 1, and then you put it right here over the 1, and then the area of the shaded region is given to you right here. And of course, the percentile corresponding to 84.13, or sorry, 0.8413 is 84%, or 84.13%. Okay? So the CDF, the cumulative distribution function, tells us about the area underneath the bell curve that's to the left of the point corresponding to your z-score. All right. Thank you for watching, and I hope that explains how to use the standard normal distribution CDF lookup table. Have a great day.